Hello, have a good day. This is the 10th and the last homework of the algorithm design and analysis. In today the topic is greedy algorithms, and the greedy algorithms is an algorithmic paradigm that follows the problem solving approach at the making the locally optional choice at the each stage, with the hope of the finding a global optimum. And its advantage is simple, easy to implement, and running fast. The time complexity is big O n if you already sorted, and otherwise if you didn't sort it, and if you have to sort them first, O n log n time complexity, and the disadvantages are very often they do not provide a global optimum solution. And actually, this is the greedy algorithm never reconsider its choices. This is the reason to it's not a global optimal solution, and that is the main difference from dynamic programming. In basically the algorithms working like this one. Let's think like this is 4, 7, 9, 11, 20, and let's say 5, and within the leaves, let's try to find the maximum sum of the numbers. And actually, it must be like 3, then 4, then 20. But in the greedy algorithms, it will be like it will take the 3, then it will check for the 4 and 7, then it will choose the 7 because the 7 is bigger than 4. Then it comes to here. In here, it's choosing the 11, and the sum of in here is 21, but in actually the exact solution like must be like this one, and this must to be 27. And to finding the optimal solution in Greek grid algorithms, the have to have two properties, and one of them is global. It must to be arrived at by selection a local optimum, and an optimal solution to the problem contains an optimal solution to the subproblems. And from the book, the greedy algorithm is for many optimization problem, using dynamic programming to determine the best choices is overkill, and simpler, more efficient algorithms will do a greedy algorithm. Always makes a choice that looks best at the moment. That is, it makes a local optimal choice in hope. It's kind of heuristic actually, and that is the choice leads to global optimal solution. And greedy algorithms do not always yield optimal solution, but for many problems they do. And the strategy for the greedy algorithms, it is a greedy algorithm obtains an optimal solution to a problem by making a sequence of choices. At each decision point, the algorithm makes the choice that seems best at the moment. Like which I said, like here, in here the in here the 7 is the best solution, so it's choosing to 7 rather than 4. And this heuristic strategy does not always produce an optimal solution, but as the activity selection problem, sometimes it does. And the process that to develop a greedy algorithm a bit more involved than it's typically. It consists of the some of the following steps, like determine the optimal substructure of the problem, develop a recursive solution, and bypass a developing recursive algorithm based, and show that if you make a greedy choice, then only one subproblem remains. Provide that it's always safe to make a greedy choice, and the step 3 and can occur in other way, which are the show that if you make a greedy choice, then only one subproblem remains, and provide that it's always safe to make the greedy choice. And the fifth element is develop a recursive algorithm that implements the greedy strategy. The sixth of it is the converted recursive algorithm to an iterative algorithm. And the steps highlighted in the detail in dynamic programming underpins of a grid algorithm. For example, the first cut at the activity selection problem defining the subproblem as Ij, where both I and j were right. We then found that if you always make the greedy choice, you can restrict the subproblems to be of the always sk. An alternative approach is to fashion optimal substructure with a greedy choice in mind so that the choice leaves just one subproblem to solve in the activity selection problem. Start by dropping the second substring and defining subproblems of the from sk, then provide that a greedy choice combined with an optimal solution to the remaining set of Sm of compatible activities yield an optimal solution to Sk. More generally, you can design grid algorithms according to the following sequence of steps. And first of all, the cost of optimization problem as one in which you make a choice are left with the one subproblem to solve. Second is provide that is always an optimal solution to the original problem that makes the greedy choice, so that the greedy choice is always safe. And three, demonstrate optimal substructure by showing that, and the ordering is could be a solution for this one. And having made the greedy choice, what remains is a subproblem with a property that if you combine an optimal solution to the subproblem with the greedy choice you have made, you arrived at an optimal solution to the original problem. And nevertheless, beneath every greedy algorithm, there's almost always a more cumbersome dynamic programming solution. And greedy algorithm will solve a particular optimization problem. How it can do it? There's not a certain way it will work all for the time, for all time. But the greedy choice property and optimal substructure are the two key ingredients. If you can demonstrate the problem has these properties, then you are well on the way developing a greedy algorithm for it. And let's take the first question from the ChatGPT. And our first question is minimum coins. And let's read it. You are given an amount of money and you need to make change using the fewest number of coins possible. The available coin demonstration are 1, 5, 10, and 25 cents. Write a function min coins that make amount of as input and returns the minimum number of coins needed to make that amount. And try to solve this problem using a greedy algorithm. You may assume that available coin demonstrating always allow for a solution. And let's check. Okay, we have 1, 5, 10, and 25 cents, and 7, 15, and 30 is asking for us. Actually, this is wrong. it's saying the 3 10-cent coins, but we can make it like 25 and 5. The output is true, but the explanation is wrong. Anyway, the 2, yeah, 10 and 5, and yeah, 5 to 2, it must be 3. Yeah, the outputs are true, but this explanation is wrong. And let's say to ChatGPT, in 30 cents output is true, this must be true, but explanation is wrong. It must to be 25 and 5 cents. Yeah, anyway, let's try to write this, and I will just copy this part, and yep, and okay, it have to take the, what will take, it will take coins, and there must be a amount, and for this one, and yeah, that's it. Let's coins not sort, no, not reserved, must be reserved. True. Yeah, because I'm writing this one because I just want to make it like, yeah, I just want to make it like, I can say it. Yeah. I just write reverse because I don't want to looks like this one. I just want to view it like 25, 10, 5, and 1. Just this for those reserve. And we have to coin number coins will equal to 0 for now. We're gonna add this one, and remaining amount always must be stated, and it will be equal to amount. And for the algorithm for coins, for coin in coins, okay, while remaining amount, sorry, bigger than coin must be number of coins will be added one more. Okay, to making the explanation for this part, I'm just going for the coins, and let me write the coins in here, 25, 10, and okay, what was this? Yeah. Okay, 25, 10, 5, 5 and 1. We reserve it in here, and it's looking like this one. If the remaining it is bigger than this one, it's just adding this one, and it will adding to the 1, and remaining amount must be equal to the decrease as in coins, and return number of coins. And did I make some mistakes? Actually not. Yeah, I forgot to show the coin, so I will just coin deno denomination. Okay, just write coin is okay. I couldn't decide to which name I should to give. Actually, this is visualization or yeah, denomination. This is a true word. Delimitations, and it will be equal to the 1, 5, 10, and 25. Yeah, okay. Then there's the minimum coins is checking for this one, and it is printing out. Let me run it. I'm not sure is this wrong or not. Okay, minimum coins missing one record. So a month. Okay, actually this is the amount, but where did I make mistakes? Actually it is given in here. Minimum coins. Okay, let me check. Where did I make mistake? The min coins just not taking this one, and okay, let me run it. Min coins amount. Okay. Yeah, that's right. It is just given the amount, and it is not taking the coins in here because I just add the coins to the coin demonstration. That's right. So actually I can delete the coin demonstration, or I can add just this one into the here. It has to go to coins and coin demonstration. Uh, isn't it? Yes, it must be like this one. So I will actually I give the coins in here so I can make it in here. So no need for this one. Right here in coins and remain okay. Coins dot sort, it is sorting, but okay, it's 7 coins, and I can delete here, and minimum coins I can delete this one. So this is must be true right now, but I'm not sure. I'll run it. Yeah. Okay. There's a error in here. What is the reason of it? I don't know. I will just go back to the first of it. Yeah, this is true. Undefined coins and amounts. Okay, it's not a problem. Okay, this one in here. So I will just copy this one and roll V. Yep, I will run it like this one, and this must be true for me now. Okay, I will just run it here. Okay, hello again. I couldn't find the solution, then I asked to the ChatGPT, and it says to me it looks like the small issue in your code. The return statement inside for the loop, so that function will return after processing the first coin. You want to move the return statement outside the loop. Yeah, as always, I made an error in return statement. It's just a simple error, but it's annoying anyway. It must be for the for, not for the while, and I'm running this one. Okay, it's given me wrong answer again. and y. Okay, let me check in here. Coins, it's giving me amount. It shouldn't give the amount actually, it should give the num coins, isn't it? And return to num coins, and actually there's a coins in here, so I can delete it simply, I guess. So I will delete this one, and undefined name coins in here, and yep, solving this one. Oh, okay, coins and number coins, num coins. It is returning this one, but the function is wrong in here, so I will do it like this one. Yeah, I will try it now. Yep, it's given me the true solution. Oh, sorry. And for this one, I have 25, 10, 5, and 1. And for the 7, it is working like it goes to 25, it's bigger than 7, then it goes to 10. Looking for this one, it is bigger than 7, it goes to 5, it is becoming 5, then the number is becoming 2, and the same process, it's coming to 25, it's bigger than 2, then it's coming to 10, it's bigger than 2, then it's going to 5, it's bigger than 1, it's becoming 1 here, then it's becoming 1, and the same process becoming, and there's a 3 number for us. And for the 25, for the 10, it passing out to 25, and 10, 5, 1. It is just becoming, it's just removing this one, taking 10, then going to here after in the second, 5, it is 2, and actually I can write in here 7 for the 7, 5, 1, 1. So the output will be 3 in the 15, in the 15. The output must be 10 and 5, so 2 in the 30. It's just taking the 25, then 5. So the answer must be 2. So our answer is true. I actually forgot to write in there's a miser in here for me. I just forget to declare the what is the coins, and I made it after the definition, and I just forget to return statement must become in the for loop, not in the while, because this one is only just taking the first one and just remaining amount actually becoming equal to the number of the coins are becoming the coins because of this one. And thanks for the listening. Have a good day again. See you.